The goal of this little model is to give you a framework to think about the household's decision about how much labor to either hire in or use from their own family on their family farm or business versus how much labor to sell to the market. At its core, we need to make this simple about how we treat labor, since I'm going to only draw this in 2 dimensions. So we'll have really one type of labor that is a perfect substitute for all other labor. That means there's no particular advantage to using your family and your family business, and that we know that in equilibrium we would expect to see, if there are no constraints, that wages equalize across all different job types. So job is a job, labor is labor. We'll begin with the firm's problem. I'm going to draw this in kind of C, which will be, or maybe we should even call that kind of dollars, consumption space, and labor space. We'll begin with the firm's production function, positive diminishing marginal product of labor. We'll set the price for the good that the firm produces to 1, so I don't have to keep writing a P everywhere. And this is our production function then, which depends on labor, and a whole bunch of other attributes like land endowment, use of inputs, productivity, that I'll just group together and call A, since they're not a choice variable in this model. Now the firm decides how much labor to use by weighing marginal revenue against marginal cost. Marginal revenue is the slope of the production function, given that I've set prices equal to 1. Marginal cost then is what? Well, this is marginal cost for labor, which is just the wage. So we'll produce where the slope of the production function is equal to the wage. And that'll give us some optimal amount of labor to use, L star, and then for that amount of labor, what's the total amount of revenue that's generated in this business? We'll call that revenue star. Now notice, if I take this wage line all the way back to the axis, we have then here, from the origin to the intersection of the wage line with the axis, the profit that the capital owner is getting. So in this case, there's some land, maybe if we're thinking of a farm, and that land has some value that's contributing to revenue. That's the portion of revenue that is generated even when no labor is being used, if you kind of do that thought of projecting that wage line back to the intersection with the axis. So in theory, if there's competitive labor markets, that's not really pure profit, but in this model, when I've written it down that I've got all these endowments that are just given, and the only thing that the farm owner or business owner is choosing is labor, all the rents that are paid to everything else shows up as profit, and that's at the intersection of the axis. Not too important for today's discussion, but worth noticing. Now let's think of the household's consumer problem. Again, there's only one type of labor here, and the household can sell it. What's the productivity of labor? W. So they'll get some amount of consumption possible for each unit of labor that they use. And remember, there's some profit that they're just nicely endowed with from the fixed factors that they own, and then the possibility for consumption just grows and grows and grows with some wage W. And let's say the household is endowed in total with some total possible time endowment T. Notice this is different than the typical consumption leisure problem that we started off with, because I'm drawing this in consumption labor space, not leisure space. So labor being the time left when you consume all your leisure. And so now, to figure out how much the household would choose to work and choose to consume, well, what's going to determine that? Preferences will determine that. But instead of having the usual indifference curves that are kind of almost C-shaped, now the indifference curves are going to face in a different direction, because as we move this way, we're getting more and more labor, which, while earning a wage and generating more consumption, is itself something we don't particularly like to consume because we like leisure. So instead, our indifference curves will look more like, let's say that, with increasing utility in the consumption leisure direction. Okay, so with this indifference curve, this budget constraint, the consumer ends up working that amount, and that gives the household then total consumption C star. And then notice that the consumption of leisure would just be T minus L star is the consumption of leisure. Hopefully by now you can see where this is going to go. We have the business's problem. We have the consumer's problem. And then we have some preferences, I'll draw those in red, that will tell us where the household wants to consume. And let's say our preferences look like this. And so that's U from consumption and leisure. And so with this, we then have a household that wants to have some optimal amount of consumption. We'll call that C star, and some amounts of total work, L star, or T minus L star to get the optimal amount of leisure that they want to consume. So notice here, how much labor does the household want to use on its farm or its home business? Well, we'll call this LH. That's the amount it wants to hire on its farm. That's where marginal revenue equals marginal cost. So how much does the household want to work? However, it wants to work L star given its preferences. Right? So if it wants to work L star, it only needs LH on the farm. What'll it do? Well, it'll sell this gap between L star and LH will be labor that it sells to market. Okay? And notice, because labor is just labor, it's completely arbitrary. Rather, the household decides to hire in labor, some other labor into the family business to get the optimal amount of labor there, and sells all of the household's own labor to the market at a wage W, or does it work a little bit on its family business and then sell the remainder of its labor to the labor market? It just doesn't make any difference. Labor's labor. It's arbitrary about the allocation between, for an individual household member, between the labor market and the home. What's key about this model is that the decision about what to consume and the decision about how much labor to use are separate decisions. And it's for that reason that we call this a separable farm household model. So this is a separable model. To make sure we understand this model, let's just work through a different example with different preferences. Here again, we've drawn our production function, our wage line, and we've chosen labor on our separately operated business to equate marginal revenue equals marginal cost. Let's say we like leisure a lot and our preferences are something like this. That then tells us how much do we want to work. Well, we want to work L star, but our business really needs L star H to be profit maximizing. So what do? Well, we'll work up until L star. Doesn't matter if it's in the market or business, and then we'll hire in that difference to profit maximize. Now notice, in this instance, I hope it'll make clear what's the revenue for your business. Well, this is your revenue for your business, but your consumption is still a little bit lower because you don't have to pay for that labor that you're hiring in. So we can call that paid to labor. Now, notice in the separable models, the business decisions are separate from the consumption decisions, but the consumption decisions are not separate from the business decisions, right? This profit maximizing business winds up with some profit, and it's that profit in part that they're consuming. So if you look in this instance where we've got some optimal consumption for the household, we have, it looks like right here, so from this region that we'll call A, that's, consumption that comes from households' labor. And then the rest of the consumption, which will go from there, down to 0, B is consumption that comes from profits. Yay. For contrast, I'd like to give you a model that's a non-separable model, where the production decisions actually depend on consumption decisions as well. We'll have my same production function as before, a positive diminishing marginal of labor, where labor is just labor. But now we'll say there is no labor market at all. So the only way that the household can earn money to consume is by working in the family farm or family business. And so then how much do we decide to work on that family farm or business? Well, we set marginal revenue equals marginal cost. What's the marginal cost of additional units of labor? Well, it's the foregone marginal utility of leisure. And so what we'll have to do is we'll have to weigh that marginal utility of consumption against the marginal disutility of labor. And let's say we wind up with preferences that look something like this, and that then gives us how much we're working on our business and how much we're consuming. So I've shut down the labor market, meaning the only way I can actually consume is through the production decisions I make on my farm. As a result, now my production decisions depend on my consumption decisions. They're no longer separate, and that's why we call this a non-separable model. Let's end with an example of a non-separable model where there are constraints on your ability to work in the labor market, but there actually is a labor market. So let's say, these constraints come from minimum wages, from regulation, or whatever, but they keep the wages very high. There's only so many jobs, so that because we want a world where these constraints are binding, I'm going to first just assume that people will work for wages as much as they're allowed to. And so there's some constraint, let's call it H bar, and that's just the most that they're able to work. And let's say that wages are high. So this is the market wage. Okay? And so because these are binding constraints, we know that people will work those H bar hours, and so they'll wind up with some WH bar, which is their consumption that they can get from working at this wage for H bar hours. Now, the problem here is that our agent would like to consume more than W times H bar. But there's a binding constraint on hours available in the market. H bar is all that they can work. So what do? What can they do to make more money? Well, there's no more jobs. That's the definition of binding constraints. So they're going to have to start up their own family farm or family business and use that to generate additional consumption. So we know that they're going to work H bar hours, which means they'll have that consumption WH bar. So what we could do is just draw then the firm or farm family business problem directly from right here, from that H bar. Now, the only way they can make money being in their family farm or business, we need to draw the production function for that. Let's say that's the production function. Notice the way I've drawn this production function, and it doesn't need to be the case, that even when you go from 0 to 1, the marginal product of labor is going to be less than the wage. So it just never would be profitable to use wage employment in this business. But I've got household preferences. Maybe this is what you want to be able to consume given your preferences. And so you wind up working some total amount L star with some total consumption C star. And when we look at the division of labor between different activities, we have 0 to H bar is in the labor market, and then H bar to L is in the own business or farm. And similarly, 0 to WH is the consumption that owes to wage work, and then WH to C star is the consumption that owns to the business. And the marginal product of labor here then depends on the choice of where to produce. The marginal product of labor depends on the marginal utility of consumption and leisure. So again, production decisions in this model depend on consumption decisions. So it is, again, a non-separable framework. Just to recap that, always, 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 consumption depends on what you do in your business. But in a separable model, your business is just profit maximizing. Marginal revenue equals marginal cost. So though business informs consumption, consumption doesn't inform business. But in a non-separable model, consumption informs business. The two are not separate.